Hello, everyone. It is a beautiful morning here in Michigan as we're starting the final video in our Beyond Blue series. It's a wonderful morning here in the spring, and I was just woken up by bird song through the window. And for the very first time, I went out and used the Merlin Bird ID app from Cornell Lab. And I was just astonished. It was such a cool experience to see um, the sounds of the birds appearing live, on a graph as I was listening, and to be able to see the names of the birds appearing as I listened to each one. I was woken by the sound of the American goldfinch, and then I added the house sparrow, the blue jay, house finch, Canada goose, northern cardinal, dark-eyed junco, American robin, northern flicker, and even the golden-crowned kinglet, all in just listening for about 3 minutes using that app. A very cool experience and a great way to start any morning as, a, as an amateur naturalist to be able to listen to the sound of birds in the morning in the spring. And, I've got a pot of coffee brewing now, and I'm sitting down to enjoy this last playthrough with all of you of Beyond Blue. In this one, where instead of actually playing through any of the dives, as I mentioned, um, last night I went and did the cleanup. Didn't take very long at all, maybe 20, 30 minutes at the most to go and pick up the last of the species that we haven't yet found, so that we have a complete science log now of all of the animals. So we're going to jump into our game, and we're going to take some time and just look at each species and add this to our written list of species. It'll appear on my blog, and keep that going for all the different video games that we play in this series. I've been looking forward to this part. So there's a couple different ways that we can see those animals. We could go into our little iPad here and go to our science log once it gets a chance to load. And you can see all of the animals this way. They've all got little exclamation marks since we've just added new data to all of them as we've been finding them in the game. But here's our complete list. And then of course we've also acquired all the different behaviors so that we can see them in the model viewer. If we come over here, we can view them here, and we can see that we've completed the list for all of them. While I was doing those last dives, I turned on the music, so this is something that you should do anytime you're playing the game, so you can enjoy the licensed tracks that are in the game. But for now, for this stream, we're going to turn those back off in respect of the artists, and make sure you get a chance to listen to those great songs. Alright, so we're going to go through from the beginning of the list with the first one that we saw, the Chilean devil ray, right? So what's neat is, here in the model viewer, we can see the animal in 3D, kind of rotate them around, and then we can go into the behavior menu and we can see different behaviors. So there was the turnaround behavior, swim fast, startled, and so on. So we could go through those lists. I'm not going to go through each behavior for every animal, but I am going to look at each in the model viewer and then jump to the science log and see the information we've learned. And I'm going to butcher each scientific name as I try to say them, because we're going to have the species name for each animal on our list. This is the Mobula terrapacana. A little bit of comedy in this stream is me trying to pronounce Latin names. Great, it's gonna be fun. In the regions detected, the atoll open ocean in the sunlight zone is where we saw them, kind of just above 200 meters. Closely related to the ocean's largest rays, found only in tropical oceans. one of the deepest diving animals, down to 1,800 meters, capable of exceptionally high speed while diving. Only in tropical oceans. And one of the deepest diving animals. I would not have expected that. While other rays have plain white bellies, only Chilean devil rays have unique markings on their underside that can be used as a fingerprint. Huh. Alright. Chilean devil ray. Now we're going to go to the sperm whale, most memorable to me as the species that Moby Dick was in the novel by Herman Melville. An albino sperm whale. In the science log, we see Physeter macrocephalus. There's quite a lot of information listed on this one. Holy cow. Another whale we see in the sunlight zone. First mature whale confirmed in region may indicate active breeding grounds. Recovered tag confirms the presence of Muri's A-lineage sperm whale family in the region. Partial census of Muri's A-lineage sperm whale family in the region. First female born within Muri's A-lineage sperm whale family in 5 years. Recording of echolocation click sounds during active hunting of squid. First recording of a buzz sound that can be matched to video for behavior analysis. We know why they click. Why do they buzz? Image analysis of the distressed sperm whale is inconclusive. Worried about the declining size of Andrea's family unit. First recorded video of a sperm whale encountering a giant squid while hunting. If only the tag hadn't gotten knocked off. Whale fall discovered near the vents. Fluke's signature confirms the death of A2, one of 2 grandmothers from Andrea's family. Biosample confirms the presence of a toxin, most likely from digesting a large quantity of prey with exposure to a harmful algal bloom, HAB. Irina suspects the HAB was a result of nutrient runoff from farms near a coastal area. Biosample confirms the presence of toxin from a harmful algal bloom, HAB. Goodbye, old friend. I promise to look in on Andrea for you from time to time. Citizen scientists from the region started messaging us as soon as we posted our recording of the dive with coordinates for where they suspect the harmful algal bloom formed. Biosample from the male sperm whale shows no presence of toxins or disease. Biosamples from the whales shows low levels of toxin in at least one whale, but not concentrated enough to cause lasting issues. Scars on A3 almost definitely from a ship strike. So all of the information listed for the sperm whales, since they were central to our story, focus in on, what we encountered story-wise with them. I would say I would like to have, more information, educational information just about the sperm whale in general in that entry. I would like to know, for example, how deep they're known to dive, like we learned that about the Chilean devil rays. But here we'll go to the sperm whale juvenile. Let's see. Go to the science log. And again, Physeter macrocephalus, in the sunlight zone. Baseline fluke and scar signature recorded for Andrea, A17. Andrea's first recorded vocalization. Andre will start training the AI to recognize her voice signature. think it is so cool that we are able not only to learn the vocal signatures of the whales, but people are using technology to, remember these different conversations the whales are having, and to analyze the language itself to see if perhaps one day we can have, conversations with these whales. Oof. Disruptive noise that seems to be causing distress with the whales in the region. Biosample from Andrea shows no presence of toxins or disease. That's a relief. Should study whether toxin can be passed from mother to baby during nursing. Okay, on to the humpback whales. Lots of information about these guys as well. In our science log, Megaptera noviangeli. Regions detected in the sunlight zone. Ah, this looks like that Merlin bird app I was using this morning. Andre has developed a song generator based on the early work of Dr. Roger Payne that we will train on humpback songs. We will try to create an original song that influences the songs of other whales. In the, I think I mentioned this during one of the dives, but in the show that we're watching that's coming out right now on Apple Plus, Extrapolation, this is one of the plots, is that, the last known whale in the world is a humpback that they're having a conversation with using AI to generate, to translate from human language into whale language, and then to translate the whale response back into English. Fluke's signature confirms it is not an individual already in the database. Whale designated M1. First recorded male humpback song recorded in this region, recorded for the whale designated M1. Male humpback song with a pattern similar to the other males heard in this region. Whale designated M2. Song pattern substantially different from previous males. This male may be migrated from a distant region. Andre will use this pattern in his playback to see if he can influence the whales singing the song from this region. Fluke's signature confirms it is not an individual already in the database, designated M21. The invisible whale. Andre's humpback song might not be good enough yet to communicate with the real humpback, but it is good enough to fool his own software. So this was them simulating the song of the humpback on the computer underwater to communicate with the whales, and the sensor picked that up as an actual whale, and we swam over and scanned it in the last dive. Second to last, I think. Biosample from the humpback shows no presence of toxins or disease. Good to see these whales weren't exposed to the toxin. Okay, moving on to the bottlenose dolphin. You can also, as I mentioned, you can see the numbers of how many individuals you have to scan in the game in order to have the full scientific data. So this was a pretty high one, 36 dolphins scanned in the game. My cat has come for a morning scratch. Alright, science log for the bottlenose dolphin, Tursiops truncatus. You can also see, of course, the length of these animals, 2 to 4 meters on each of the first screens here. Also seen in the sunlight zone. Known to use tools, cooperate with other species while hunting, and transmit these behaviors from generation to generation within their groups. Pleased to see a healthy population of young dolphins in the region after the crisis that impacted the population of whales and dolphins throughout the Pacific. The antimicrobial properties of these coral are being studied for how they might help the dolphins resist infection. Signature whistle recorded. Pleased to see a healthy population of young dolphins in the region. Same text as before. After the crisis that impacted the populations of whales and dolphins throughout the Pacific. So the bottlenose dolphin. Alright, next we had the orca. Learned that we had these cool little fingerprints on their backs, behind their fluke there, or their central fin, I guess. The science log, these are Orchinus orca. Different sizes for male and female listed. Seen just on the edge of the sunlight in the twilight zone. 200 meters or so. Saddle patch, that's what they're called. Saddle patch pattern scan to help create a digital signature for this individual. Andre will post the ID on the OceanX network to see if any scientists are tracking these orcas. It's really cool when you can use something that is naturally occurring on the animal to identify, like shape of the tail or these saddle patches, rather than having to artificially tag and track them to recognize individuals. The vocal signature recorded. Orcas haven't been previously documented in this region. the sound of the orca whale mixed with the sound of me sipping my morning coffee. So orcas in threatening formation, mostly likely having sensed that Andrea and her mother were vulnerable. Biosample from the orcas shows no presence of toxins or disease, but seriously undernourished. DNA signature is a match for an orca recently released from captivity. Alright, the leatherback turtles. Of course we're still in the sub, underwater, so we have other animals swimming by in the background as well. 1.8 to 2.2 meters, and Dermocles coriacea. Dermocles coriacea. That's my best attempt. We saw them in the twilight zone between 200 and 1,000 meters. Leatherbacks thought to have been wiped out in this region. Biosample collected to obtain a genetic footprint and see if it might be related to the one of the small remaining populations. Lots of little typos in the game here. They needed an editor, perhaps an English major. I could have helped a little bit here. Genetic footprint from first turtle did not match any known populations. Arena will compare this turtle's footprint to the first turtle to see if they are related. And we saw some cool citizen science about people helping out the leatherback turtles. We have leatherback turtle baby, lots of information with this one. Once again, Dermocles coriacea, the twilight zone, threatened because of warming beaches and human impact. Andre discovered teenagers were using DIY seawater irrigation to help cool the nests of the baby turtles to help the population recover. Biosample to determine sex and log genetic footprints. Age suggests the turtles may have been born on nesting beaches nearby. More baby turtles starting their journey in life. Let's hope the cooling tech those teens are using for their nests can be scaled. Maybe Arena can fund them. We have 5 pieces of information there. When we open the science log, let me go back here. Oh, right, so that was my mistake. I was seeing that 11. That was how many babies we scanned, not how much information we have. Northern Pacific sea star is our next animal to look at. I'm actually really curious about what the behavior modeling is here. Yeah, there are none. Okay, we hit behavior, nothing happens. It's because they're not doing much. Asterius amurensis, up to 50 centimeters. Seen in the sunlight zone. Dishonorable mention for being on the list of the world's 100 worst invasive species. Not their fault though. The larvae are easily transported around the world by people in the ballast of ocean vessels. Despite having only a primitive nervous system and no brain, sea stars are carnivores, preying on mollusks, can regenerate lost limbs, which makes them a promising subject for Arena's research. I don't really think I paid attention to the no brain part earlier. That's fascinating. Primitive nervous system and no brain, and yet they're carnivores. Wow. Invasive species to the region, possibly introduced from the ballast water system of a ship. Andre is testing an automated drone for the safe removal from the area. Northern Pacific sea star. Next is the giant clam. See the movement there. This one is Tridacna gigas. Seen in the sunlight zone. Largest living bivalve and vulnerable to extinction due to overfishing. Hundreds of pinhole-type eyes line the mantle, allowing it to detect predators and shut its shell in response. Wow, that's fascinating. I assume something like the simple eyes that insects have, in addition to their the bigger eyes that actually can see the world around them. They detect light and so on. That's incredible. Hundreds of pinhole-type eyes, allowing it to shut its shell in response to a threat. Largest living bivalve, though. Our giant clam. We saw lots of spider crabs. Very cool. I love being able to see that animation up close. We can actually zoom in on these creatures too. We can see even closer here. What a cool animal. Platyemea barchi. I see, scientists rolling their eyes at the way I pronounce these, but a good faith effort. And then we've got 6 to 7 centimeters of the body. They haven't measured the length of the legs from end to end, but in the twilight zone we saw them. You can also, of course, see the regions detected here. So we saw them in the seamounts and vents, for example, not in the open ocean. Many deep-sea animals are not adapted to see the color red because those light wavelengths don't penetrate very far underwater, making these guys effectively invisible. Interesting. Feeds on dead animals that sink from the surface. Thin legs are an adaptation to the low oxygen environment where they live. Alright, on to the first of many fish. This is the royal angelfish. Got sort of an orange and white tiger striped pattern there. The really different blue and red lower fin and a bright yellow tail. This one is Pygopletes diacanthus. In the sunlight zone, likes to swim around lagoons or reefs and is sometimes found in caves. Carnivorous, feeding on sponges and tunicates. Some scientists believe the patterns on their bodies are used in communication or indicate social position. Colors change a little with age. So that's the royal angelfish. Next, the mailed butterfly fish. Nice to be able to get a much bigger, closer look at them here than you can see when you're actually on the dive. The mailed butterfly fish, Chaetodon reticulatus. In the sunlight zone, has a characteristic black eye band, feeds solely on live coral. Monogamous relationships? Rare, right? the mailed butterfly fish. So that black eye stripe is apparently, or that black eye band is apparently an identifying marker. Now we have another butterfly fish, this one the black wedged butterfly fish. There's also a black eye stripe on this one, but it doesn't cover as much of the face. Black wedged butterfly fish. This one is Chaetodon felcula, so this is the same genus. That's why that would make sense with the common name butterfly fish, but the species is different, felcula this time, felcula, and that also indicates why, if we say butterfly fish, we're referring to the genus Chaetodon, which the last guy and this one both fall into. But when we say black wedged butterfly fish, we're indicating a species. In this case, felcula. We saw them in the sunlight zone. This species, Chaetodon, has a characteristic black eye band. Butterfly fish form monogamous pairs, like to have places to hide. So actually, we could correct this here by saying this genus, Chaetodon, has a characteristic black eye band, and so it is correct to say, when I noted that there's a black eye band here, and on the last one, that's something apparently that's true for the genus. I think that's what we're being told here. So we'll go back and we'll look and see the mailed butterfly fish. Black band around the eye. Oops. The black wedged butterfly fish. Same black band around the eye. Both in the genus Chaetodon. So two species from the same genus. We may have the same thing happening with the next two fish. I see the Koi's parrotfish and the tricolor parrotfish. So let's glance real quick at their species. This is Scarus koii, or koi, Scarus koi. And here we have Scarus tricolor. So indeed, parrotfish indicating the genus Scarus, and then the kois, which we'll look at first. Let's first take a little look at them. Really gorgeous colors. And I have to say, for me, when I hear parrotfish and then I see the face, there's something about the face and an almost beak-like appearance that reminds me of a parrot, so that's fitting. But this one, Scarus koi, the Koi's parrotfish. Seen in the sunlight zone, their teeth resemble a bird's beak, which is specialized to scrape invertebrates and algae off of coral rock. They change sex often throughout their life cycle, and when they do, their coloring changes too, which makes it extremely hard to classify them. That is wild. Wow. I wonder if that's true of the tricolor parrotfish as well. Now that is a really cool colorizing. I like that. Alright. Scarus tricolor. Seen in the sunlight zone. Parrotfish are hermaphrodites and live in harems with a dominant male, same as Koi's parrotfish. They are not territorial, living and feeding in harmony with other species. So a genus of hermaphroditic fish, including the tricolor and the Koi's. These are the parrotfish. Okay, next we have two more of the same, possibly the same genus, the triggerfish. We'll take a quick peek at their species name. Ballistoides conspicillium. Conspicillum, there we go. Balastoides conspicillum. And then we'll look at the Titan triggerfish. Balastoides viridescens. Yes, so again, two members of the same genus, as indicated both by the scientific and the common name here, triggerfish. The first kind of triggerfish we'll look at is the clown triggerfish. Interesting spotting pattern on its lower half. It's got a little yellow mustache. Balastoides conspicillum. In the sunlight zone, aggressive and dominant with powerful jaws and sharp teeth, hides in small crevices and is capable of cracking shells open when hunting for food. Triggerfish are named for their special dorsal fins that compose a trigger system they use to scare predators. The first fin can become erect, causing the second, larger fin to lock outward in place like a trigger. Curious if there's no behaviors that we can model for this fish, but it would be interesting to see that. So this is the clown triggerfish. Now we're going to look at the Titan triggerfish. It's just incredible, like all of the different color patterns that you can find on fish. It's like everything has been tried in evolution. Balastoides viridescens, the sunlight region, sunlight zone, largest triggerfish in the Indo-Pacific, solitary fish. Their teeth are adapted for crushing shells and coral. Small fish will usually follow triggerfish around because they stir up detritus for little fish to feed on. So the Titan triggerfish and the clown triggerfish. Next we have the white-spotted pufferfish. This one is Arothron hispidus. In the sunlight zone, finds its food by shooting jets of water into the sand, exposing invertebrates hidden underneath. When threatened, can clamp its gills shut and inhale water into the stomach to rapidly expand like a balloon to 2 to 3 times its normal size. The species has a toxin in its skin which it releases when highly stressed or dying. So that would be another cool behavior. It would be fun to model. There are no behaviors that we can view with this species, but it would be fun to see it inhale that water and grow 2 to 3 times its size. With the white-spotted pufferfish, we also have the blue-green damselfish. Iridescence there. This one is Chromis viridis. Sunlight zone. School around coral reefs, specifically Acropora coral. Damselfish are egg layers. First they clear a site ready for a nest, then engage in a mating dance with rapid swimming and fin movements. Damselfish reminds me of damselflies, you know, the name damselfly. So we have the blue-green damselfish. Then soldierfish. He just really, you know, from certain angles, he has a really sad looking expression. He's really distressed. This one is Muripristis burnti. In the sunlight zone, large eyes are adapted to hunting at night. During the day, likes to hide in caves or under ledges. Soldierfish got their name because their colorful patterns are reminiscent of 18th century military uniforms. I want to take a second here to point out another really cool thing that I've noticed about the game, which is that when you go back into the optional dives after you've completed the game, in the story dives, we had Mirai giving us an update, and there would be an image of Mirai on the screen and then kind of a journal entry from Mirai. And now when you go into the optional dives, alternatively, there are pieces of scientific information that show up on the screen. So to share a couple examples, one of them was this piece of information right here. Soldierfish got their names because their colorful patterns are reminiscent of 18th century military uniforms. Another one I saw was the moon jellyfish are a master class in survival. They can effectively age backwards by reverting to an earlier developmental stage and regenerate lost body parts. Another one was many deep-sea animals are not adapted to see the color red because those light wavelengths don't penetrate very far underwater, making spider crabs effectively invisible, which is a piece of information we just saw with them. And this is a new one that we did not see with the sperm whale. The sperm whale's name refers to spermaceti, a waxy substance produced by an organ in the whale's head. The whales were once heavily harvested for their spermaceti, which was used to make candles, among other things. So I'm interested to know how much of this information is available in the optional, return dives, and how much of it, you can't see elsewhere in the game, if that's a thing. But this one reminded me to mention that, since I'd seen that one in one of the loading screens on the dives last night. So there's our soldierfish. Now we know how it got its name as well. And those big eyes help us see in the dark. Alright, the splendid Alfonsino. That was one we found again on our first dive. Again, real big eyes. Barracks splendens. In the twilight zone. Big eyes because it lives down deep. Bigger eyes let in more light. Possibly lives up to 50 years. Very deep-dwelling fish. Migrate upwards at night to feed. 50 years. This tiny little guy. Alright, the great barracuda. When I was a kid, this was one of the scariest things in the ocean, reading one of those kid nature magazines, and it was like learning about piranhas and barracudas, and it was like piranhas were the bitey fish, and barracudas were the even bitier fish. This is Phyrina barracuda. Seen in the sunlight zone. Top predator on the reef. Powerful jaws. Hunt by ambush. When hunting, bursts into speeds almost 60 kilometers per hour, or swims around schools of fish to trap them. Can hunt as a group. Next, the remora. Swimming upside down as we saw him, attached to the belly of the whale shark. Remora, remora. Well, that's an easy Latin name. In the sunlight zone, sometimes called suckerfish. The The first dorsal fin is a special disc-shaped organ on top of the heads with slat-like structures that open and close to create suction, used to take a firm hold against the skin of larger marine animals. That is fascinating. And also, I have already realized my mistake. This guy is not upside down. His lower jaw is just, extends longer than his upper jaw. He's right side up. That is wild. He's got two fins up top to help maybe stabilize as it's, attaching to the body of a larger animal. And this organ is fascinating. It's like a nature's own suction cup. And it would make sense that the lower jaw was a bit longer if it was, eating food that was sourced from above its head. That's fascinating. You see it and you're like, well, that guy's upside down. No, it's not. That's so cool. Capable of attaching to whales, turtles, sharks, sunfish, and even boats. While attached, it eats away parasites and old dead skin. You see a bunch of them attached to the whale shark there. Wow. That's cool. Alright, the spotted sardinella. Another tiny little guy. Sardinella, reminiscent of the word sardines. Up to 27 millimeters. Seen in the sunlight zone. Giant schools migrate along the coasts to eat plankton. I'm not sure this word. Deal vertical migration. Follow the plankton deeper during the day, closer to the surface at night. So we saw a big school that was being herded by lots of cooperating predators. Spotted sardinella. The pilot fish. Up to 70 centimeters. This is Neucrates ductor. Seen in the sunlight zone. Found swimming around sharks, rays, turtles, or even boats. Maybe around our sub. Similar to remoras, but do not attach to the animals they follow. So they like to follow others. Young are usually associated with jellyfish and drifting seaweed. Eats parasites, food scraps off of larger fish. Mutualistic relationship. Oh, there was a Titan triggerfish swimming by in the background. And some sharks. Let me see if that was correct. Is that right? Yes, that was the Titan triggerfish swimming by. We also seen the ocean sunfish swimming by the sub, which was always very cool because, man, they're huge. How big they are. You just don't get a sense of the size until you're swimming next to it. And you're like, man, that is a big guy. And such a strange, like that fin on the top and the bottom, and then the two small fins on the side with this giant wedge of a tail. Such a strange anatomy, physiology. Alright, this is Mola Mola, probably the easiest scientific name we're going to encounter. Mola Mola. Right on the edge between sunlight and twilight zone. World's largest bony fish, weighing over 2 tons. My gosh. Extremely susceptible to parasites on the skin. Smaller fish are often found swimming nearby because they like to nibble off the parasites. Everybody's got to eat. Now I wonder, when they say bony fish, this specifically, does this not include sharks, for example? Because I'm thinking, like, does the sunfish outweigh a whale shark? Or is a whale shark not really considered a bony fish in the same sense? Not sure. What a big guy. 2 tons. Now the John Dory. Now that looks like your stereotypical professor of literature. Or perhaps a history professor, you know. Disheveled hair, very pompous expression. Mind your own business. Zeus Faber. Right on the edge of sunlight and twilight. The John Dory has a very characteristic eye spot on the side of the body, which both confuses prey and scares predators away. They eat by stalking prey and shooting out their jaws to siphon prey into their mouth. That, again, would be a cool behavior to be able to see here. But that eye spot is significant. Protection. Alright, the John Dory. Next, the Orange Ruffy. Another guy that looks kind of distressed with that downturned mouth. Oh boy. Hoplostethus atlanticus. Hoplostethus atlanticus. Found in the Twilight Zone. Fishery trade changed their name from slide heads, mucus-producing glands, to make them more appealing. Slide heads. Overfished now and on the IUCN Red List. One of the longest living marine species. 150 years. Oh my goodness. There is a slide head out there, or a orange ruffy, that is going to live double the length of my life. 150 years. One of the longest known marine lifespan. Incredible. The silver chimera, we missed these. I had to go back and find more of them in the cleanup dives, but they were down at the the ocean bed, and we kind of swam over them in the story dives. I think his face is kind of adorable. This is the Chimera phantasma, seen in the Twilight Zone, pretty close to the Sunlight Zone. Gets its name from the stitch-like pattern on the skin that gives it the appearance of being sewn together, like the chimera from Greek mythology that combines a snake, lion, and goat. Wow, that's interesting. You see the stitch-like pattern there that makes it look a little bit like a Frankenstein's creature? That's really cool. Yeah. It's an easy to miss feature that it's really noticeable once it's pointed out. Shares many characteristics with sharks. Cartilaginous skeleton, male claspers for internal female fertilization, eggs encased in leathery pouches, and electroreceptor sensory organs in the snout. Next we have the barrel eye fish. Wow. You can see right through its skin to those membranes. Kind of a stumpy little tail there, but really big fins all around. Okay, this one is going to be another challenge. Opisthophractus. Opisthophractus soleatus. Opisthophractus soleatus. In the twilight zone. Doesn't move much. Still manages to capture small prey like planktonic crustaceans. Eyes can rotate within a transparent shield that covers the head. Green pigment in the eye may help filter sunlight to aid in spotting the bioluminescent glow of prey. So those are actually the eyes we're seeing. They can rotate within a transparent shield that covers the head. And that has green pigment in them. So those things on the front are not eyes. The eyes are inside there. You can see them below that transparent membrane. Very cool. The barrel eye fish. And we're going to do one more species here on this video, and then we'll break the second half of this examination of all our species into a second video. But we're going to look at the lanternfish last of all here. Looks like it's got some bioluminescent scales there. This one is the Myctophum. And when we see this, by the way, SP period, we're not identifying the species here. We're referring to the genus lanternfish, Myctophum, the genus. So we don't have an actual species here. We'll just be listing this one by genus, the lanternfish. Seen in the twilight zone, we saw them in the brine pool. Swims up to the surface during the day and back to the depths at night in a process known as, that could be diel or diel vertical migration. Thinking maybe diel vertical migration. We saw that term just a bit ago. The lanternfish. Okay, so I'm going to end this video here, and we'll pick up on the next animal, which is the split fin flashlight fish. Thanks for watching.